Previously, I said that you can prove this by boundedness. Let's prove it by squeeze. Let me recap. This Bn is my stuff. Squeeze theorem is to find two guys. One is smaller than me and one is larger than me. Then how do I make An? This is a good example to use squeeze theorem. This thing I can just say this. Why? Because among all the possible ways you can make a denominator, I just plus 1. My denominator is always larger than this. So the denominator of my An is always larger than Bn because this is either plus or minus. Then if I always plus, my denominator is larger. Larger denominator means smaller, right? And at the same time, this is a numerator. I always pick the smaller one. Then this An I construct in this way will be always smaller than my Bn. How do I make my Cn? Well, I just pick the largest possible case I can get. That is, for the numerator, I pick the largest possible case, that is plus 1. And the denominator, I pick the smallest possible case, that is minus 1. Then I have my An and Cn. Then you prove these two converge to 1 for the limit. Then by squeeze theorem, it converges to 1. And here's a funny thing. You can put a 7 here, right? If I add 7, this whole thing is still bigger than my Bn, right? So, or I put a 71 here, I can do that, right? Because if my numerator is bigger, then of course it's bigger. So if I put a 71 here, what happens is that this is Cn, right? Then there will be a 71 here. Which doesn't matter. 71 divided by square root n for n go to infinity is still 0. This shows the way you construct An and Cn is not unique. You have infinitely many ways to find An and Cn, and that's it. And this is the idea, okay? So this, in using An and Cn, they all limit go to infinity is 1, so by squeeze theorem is 1. Of course, you need to show An smaller than Bn and Bn smaller than Cn, but I have all the argument here.